you want to run through the slides, or do you want me to do it?
Yeah, I think you can run through the slides and then I can share some plots.
Sounds good.
Some demos. Yeah.
Okay. I'll share the screen. Okay. So I'm glad we can get to this. So we didn't have time really to dive into it during the on-site. Okay. So just a really quick high-level view of the first few iterations of the IMT tool was a template-based matching algorithm. And that was a good way to do it with a smaller data set where you have a library of really good examples of what the intimate region looks like, for different angles, for different kinds of images. And John Marinakis built a system to match all those templates for every new IMT image that's coming in, and then you could use that to figure out where the correct region is, segment that out, and then once you have that region, you can measure the average thickness of that region. So you guys have seen that. Here's just a really quick summary of the different releases of that template matching region. So basically, there's just some updates every time, from the initial set to additional filtering, a little bit better thresholding, filling in the holes in case the image had very low contrast, so that would be a little bit more representative of the anatomy without holes in it, and then fixed a very small bug for the last version. And then, at least based on our testing, it looked like for the vast majority of the time, it was matching the ultrasound text manual measurements very well. For this, and overall performance was good. But then in the meantime, once we had CVAT and new images coming in from the Bonsai, that gave us the option and the opportunity to build a more robust model with a whole lot more data coming in, especially with a lot more CVAT annotations. And the image quality on the Bonsai for the CVAT was better than the Sonosite. So we had ability to provide more information to a new model. Okay, so I guess to make a long story short, we've shown that you could use this CVAT web-based drawing tool to make it pretty easy to draw the CVAT, the IMT annotations on there, so we put together a big job for that, collecting all the IMT images plus a trickle of IMT images coming in as new studies were available and done on CVAT. And with that, we got, I think, about 6,000 images so far that we use for the latest version of the neural network training. I won't go into the technical details of this, but this is just an example architecture of a U-net. It's called U just because this is the shape when you draw out the structure, all the different layers of the neural network. Kind of has this U shape. So it's basically a way to use multi-scale views of that image to train the neural network in order to recognize shapes on the network. And this has been working really well for a variety of machine vision tasks and competitions. So it was a good place for John Marinakis to start to see how the performance is.
And to add on that, U-net is usually in a lot of medical applications. That's the main reason I selected this network, because it's proved that it's working in grayscale medical images.
Yeah, that's a good point. Yeah, it's pretty robust kind of model for this application. Okay, so now that we have the next thing we wanted to dive into was to figure out this discrepancy between the different ways of measuring the IMT. John and Jay let us know that in a lot of cases they were seeing a discrepancy, and we were trying to dial in to figure out why. One reason could be that it's just a different way of drawing it, that the SonoCalc assisted tool in general produced a slightly different thickness than if the same person could do freehand drawing and see that. Or another thing that was a little bit hard before we did this comparison study was it was hard to compare apples to apples, really, because before we had the screenshots in SonoCalc, we didn't know exactly which images were used for the measurements of SonoCalc and which regions of the image were used. so we could see exactly how much there was agreement between SonoCalc, CVAT, and AI. Different regions. There could just be differences across the text. People doing it. Maybe one person just happens to, think to draw a little bit thicker than another person, and we don't have enough people doing this right now to answer that part of it definitively. But I wouldn't be surprised if there's like a 5 or 10% difference in just how people tend to draw that region, especially since it's so thin in general. And another thing we wanted to know is how, even though we have a lot of images, do we feel like that it could be better if we had more data, or if it's kind of at a performance plateau where it's already well trained? Okay, so we'll dive into to these specifically. There's a couple interesting points that we can think about through this. One is that even if there's a difference, at least to my eye, sometimes it's hard to determine which one is best. Like I know the SonoCalc is FDA approved, but it's a much older piece of software, and it has a lot of abrupt jumps that we'll see in a second. So it just doesn't seem like it's very representative of the anatomy if you zoom in, if it has a lot of jumps. And then the second is, this is an interesting question in terms of the report. So since vascular age is how this thickness is kind of interpreted and presented, I don't have a good handle yet on how that's translated from thickness into age. So if we have something like an X% discrepancy in thickness, how much does that actually matter in terms of the age? And so that would be a follow-on study that we could do for this.
And Joe, this was the thing I was asking you about yesterday. So as we go through the near the end of this section of the discussion, maybe we can talk about how to best measure that. And I know, John, I think you're calculating the vascular age based on a lookup table or something like that. So maybe we can talk about doing some validation of that as well, which I think will be a good thing.
Okay. Okay. So in general, the neural network, the new model of the IMT region, I think is working really well. Hopefully, this is coming through okay. So what we're seeing here is the SonoCalc screenshot, and then the IMT segmentation mask, and then the CVAT mask. And so if you zoom in, let's see if I can zoom in here. Just and there's a whole data set of results images that we can flip through one by one if you'd like. But yeah, this is a really typical example we see from the AI, where the shape looks really nice and clean. It looks very good to me. If you compare the CVAT, which is this kind of pink section, to what the AI did from from its training model, it agrees very well. There's always a little, I guess, wiggle room in how wide to make the image. I know that the SonoCalc one, I think, was clipped to be 10 centimeters, if I remember right, but this one, or 10 millimeters. But I guess as long as the thickness agrees well, it's fine. If you zoom in on the same one, this SonoCalc region doesn't look very different. Some of them, I guess we'll see, have much bigger jumps that make it a little hard to figure out if the average thickness from something with a lot of jumps is more or less trustworthy from the more modern smooth shapes that you get from these images.
Yeah, good point.
Yeah, but anyway, I'd say that the neural network version of the model is working really well, and it's, we can begin looking at that in a larger scale and see if that is trustworthy enough to put into production.
Nice.
There were two questions. Oh, I'm sorry, go ahead, John.
Jonathan, is that it's very, very good, and that really one of the reasons we've been so careful to keep SonoCalc working is the fact that it does have an FDA approval.
Sure.
But at the same time, we have a new solution for that, which is that the bonsai itself has an FDA approval on it.
Oh yeah.
So as we save the IMT measurements from the bonsai and we OCR that, we can use that for our comparison if we ever decide that we need to have some sort of comparison on an FDA level.
Okay, great. Yeah. Thank you for bringing that up. That was one of the follow-on questions I had. Is it if the workflow is going to shift more toward bonsai IMT measurement, it might be good to repeat this study and just compare the agreement between AI and bonsai.
Well,
Yeah,
and Jonathan,
and I think the problem there is that we won't be able to use that bonsai on third-party ultrasound machines like we can the Sonocalc.
Okay.
So it becomes that's the one gotcha that we have when we try to leave Sonocalc.
Okay, that makes sense.
so then if we wanted to extend the results to compare bonsai, we'd have to start with a bonsai image that used the bonsai IMT measurement feature.
Yeah, but I don't think that's critical right now. I'm just saying that 2, 3, 4 months from now, as Joe has already stated, we can move forward with this if we feel comfortable without FDA approval, as long as we keep it in-house.
Gotcha.
Yep.
Okay. Makes sense. Now I know this was a really tiny study, only 200 images here, but I was happy to see that there is very good agreement across them. In general, across a small data set, the CVAT, which is this orange histogram, that the text tend to draw just a little bit thicker than in the Sonocalc, which is the dark blue. And then the AI was kind of halfway between the two.
Huh.
And then you
Nice.
could see, yeah, for most of them, there's really good agreement. There's a couple outliers that's interesting to explore, and those usually happened if the image quality wasn't great. It was a really low contrast, and sometimes that was a little hard to get agreement. But overall, I think it's looking really good. This is the Sonocalc versus CVAT, so basically just measuring a difference in the drawing tools. Here is how well the model trained on CVAT would reproduce that kind of drawing. And yeah, I was looking into these are just very low contrast images that confuse the model for these. So this another way to deal with this is if just like you're doing to get multiple examples of images for the same patient, and then it's pretty easy to see if there's an outlier across the measurements. And then here, the Sonocalc versus AI, probably the most interesting one, also very good agreement. And we can pull up examples of these where we have low contrast, where the model got confused. Okay, so for next steps, yeah, just as we were talking about before, I think it'd be helpful for just number one, figuring out the tolerance. If especially in preparing for an FDA application one day, is to just translate the X% difference we see from a FDA approved device to a new workflow, if we need to, and just see how much does that actually matter in terms of the output of the report, and especially in terms of vascular age. And then we can start looking at the bonsai measurements too, if that's going to be the new workflow, at least for the devices that your team is using.
Yeah.
Okay.
Great question. Great next steps.
Okay. But yeah.
What do I do on how much IMT difference matters? Is that we look at the data and then decide if we're happy?
No, that's
with
the
it?
table. That's just the lookup table. You just look at the table value and it's extreme. You have a very small IMT difference and it makes a huge difference in the lookup of the vascular age.
Okay.
Oh yeah, like
There's no study
0.03
needed.
millimeters.
Table.
Gotcha.
Okay.
That's good to know. Okay. And then the other thing is that'd be interesting is at least some sort of subjective call on across this study about which shape that the ultrasound techs think is more accurate to the anatomy. Especially because the Sonocalc has these jumps. So maybe just some sort of quick tally of, do they seem equivalent just visually to them, or is one definitely better than another? That would just give us a little bit extra data to if we do measure an 8% difference or something across the two, how the best way to interpret that.
Which one we think is more?
Yeah,
You're asking a subjective call on which one, or yeah, which one we think is more accurate.
Exactly. Yeah.
Dude, clearly it's yours. I mean, in anatomy, it's those big jagged on the sonocalc or not.
Yeah.
I can't. You're right. You nailed it.
Yeah. Okay. So that was just
I'll
the
ask
way.
him.
Yeah. And we probably just need to be prepared along those lines. If, you know, when we do the FDA application, to say, even though there's some X% difference, you know, the going through, we think that's just because the old way has these, you know, unrealistic jumps, and the new way is better. So something like
Yeah.
that. Okay.
But also comparing to the same measurements taken on using the bonsai feature may be helpful as well, right? Because this is old technology. So comparing the AI results to a more recently certified FDA approved method, the bonsai method, may be a fairer representation of our.
Yeah. The other interesting difference about the bonsai is that it's kind of halfway between the sonocalc and a free drawing tool like CVAT, where, as Jolene was demonstrating to me, you know, it takes its first crack on it, and it's more smooth than the sonocalc one. But if she just doesn't agree with the shape, you know, or if the initial quality metric that it shows is not high enough, she can just draw manually on it, and it has like a nice smooth shape that that looks more similar to what we're getting on CVAT, and save that. So I expect to see that there's going to be a lot higher agreement between bonsai and CVAT than between sonocalc and CVAT.
Yeah, I agree with that too.
Okay. Okay.
Wow.
And we have a whole bunch of results that's, you know, I guess if it's interesting, either now or later, we can flip through on a case-by-case basis. But in general, oh yeah, John has it up here. You can just see quickly as you go through that these are, you know, it's hard to find one where there's a big disagreement. Yeah. He was pulling up some of the examples.
Yeah, you're not kidding. You got this. So I found out the videos on the bonsai are 100 video slices, like a lot.
Okay.
If I ran a video of 3 heartbeats, which I can do on the ultrasound machine, could I measure each one of those 1,000 images and get like I mean, how much incremental work would that be?
It wouldn't be that hard. You know, just running a loop over all those images and saving the results, and then getting the distribution of thicknesses across all those images, and then coming up with the one metric, like the average measurement, for example.
Yeah. Because if we just document all the plaques and get a video loop of 3 beats, that could shorten the acquisition time.
Sure.
And increase the quality.
Sure. Yeah. Yeah, that would be a pretty easy workflow. Just pointing at the right part of the anatomy, take a quick video, and save.
Yeah, love it. Man, this looking at this feels like you guys cut and stacked a pile of wood. Like, it's satisfying. It's work that's done. It's nice.
Yeah, I think, Rich, you can share those figures with Joe. We have those uploaded, so you can have a more, you know, detailed look. And yeah, in a lot of cases, as Jonathan mentioned, if we can see this shape right here, to me, here I see a gray area, right? So
Yeah.
it's most likely IMT. But because if this area is not drawn, this surely affects the average measurement. And if we see the average measurement, well, in that case, it's pretty close. But in other cases, like, let's find one. Yeah, for example, in that case, like, we see some up and downs right here.
Yep.
So the measurement looks like 0.61, and here we get 0.62, which is like 1 pixel difference, right? So I don't think there is any significance on this small difference. But in that case, for example, the result is 0.7, but we get 0.77. Although the problem here, I think, is that we are we have detected a much larger area, right? At this point,
Yeah.
we don't limit our measurements at 10 millimeters. We can do that. It's not super hard because we know the pixel size, so we can like calculate a 10 millimeter distance and crop
Yeah.
the mask somewhere around here. And yeah, if we do that, it will be identical with the region that the technician selected. So there are some cases like that where we overestimate because the network sees all these IMT areas, so this area is going to be segmented.
Yeah.
So I guess the question for John, for Joe is the 10 millimeter sample size that we see on the left side with Sonosite, is there a reason for that? Or is there any reason why we should want to have the same size sample, or is the larger sample area more accurate and desired?
Yeah, I'll tell you guys what I know is that in the research, they describe acquiring or measuring the IMT that it's 1 centimeter proximal to the bulb. So it's a 1 centimeter length,
Okay.
blah, blah, blah. Do we think that we can get better data by getting a longer average?
That's, I think that's where subject matter expertise comes in.
I'd rather match the research than,
Sure.
but that's all the information I have.
So
And
1
also-
centimeter proximate to the bulb. So that means like from the bulb, we are looking for a full 1
So
centimeter.
where the artery, yeah, where it flares into 2 and where it just starts flaring, you want to measure 1 centimeter. So in that image, kind of, yeah, it's not always easy.
Well, my guess is that the 10 millimeter distance, it's this green box. So I think this is 10 millimeters. For example, in that case, I think this is not 10 millimeters of IMT. I can almost send about that. And
I think that box is just the region of interest.
Yeah, well, I think it's reasonable for that to be 10 millimeters if we think about the pixel size. I think if we can do the math, we can find out if that's the case.
Okay.
Because like if you think about it, the IMT measurement, the mean thickness measurement, it's like 0.8 or something like that usually. So I think it's reasonable for this distance to be 10 millimeters.
Yeah.
But even in that hard case where the contrast is a bit bad and blurry, we still get a small area and we actually get a number, which is very different than the ground truth one. But
yeah,
to me,
those aren't great images.
ground truth doesn't seem very right.
Just out of
Agreed.
curiosity for this one, what is the CVAT measurement thickness?
See that it's like 0.8, so there is a lot of variance in this specific example.
Okay.
But again, that's a very difficult image.
Yeah.
Okay.
And also, like in that case, the technician draw here on the far right side, not near to the bulb. And I think that's the case because here the IMT was more clear.
Yeah.
She didn't took this part, right? So it's a bit subjective about the right region to draw the IMT. But,
No, but
usually,
we just heard from John. We just heard from Joe that the standard is 1 centimeter approximate to the bulb. So do we need to account for that in our model?
Well, as we're thinking about that, I also heard from Lisa that they can use a little of their judgment too, because if there's something going on, like if there's plaque infiltrating the artery wall, they don't want to get too close to that because there's a lot of inflammation around there. They want to get far enough away to get a more trustworthy measurement. So it's a kind of a subtle problem to optimize.
Yeah.
Yeah, and the last thing, we generated this spreadsheet where we're comparing the 3 methods. So Sonocalc, AI, and CVAT. and we calculated the differences between those three methods. And if we go to the averages section right here, we can see like in the drawings from CVAT and Sonocalc, there is an 8.5 difference. And both those drawings were produced by technicians. So like there is a small difference even in the ground truth data.
Yeah.
Our comparison, the AI comparison to Sonocalc, it's just a 6.8. So it's very small. And my guess is that it won't change the calculated arterial age at all, because I think the error is small. But we have to validate that by calculating the arterial age using the lookup table you are using.
So would it make sense in terms of the IMT work that remains? We've got well-documented results. It's a relatively small set, 200 studies that we've done this on, but both the quantitative and the qualitative, when you look at the images, looks extremely good. I think the last steps that I've got here for closing out on IMT are delivering the final code and documentation to GitHub. So John, you're going to be working on that, and you'll be able to deliver that up to GitHub by close of business on Monday.
Yeah.
John Murray can have access to that. And then the other thing I think we need to look at is just what the percentage difference in the CIMT measurements across the three different sources, how that impacts the calculation or the lookup of the vascular age. So John Murray, is that something you're already doing that? So is that something that you could validate for us easily? Just given the measurements that we've got here, running it through whatever code, or if you've got some sort of routine that does the lookup for each of the three methods that we've got here to calculate based on the lookup what the vascular age is, and we can look at any deltas.
So you'd like the table that gives back the vascular age based on the IMT.
I think that makes it, yeah. Do you agree, Jonathan? That's a good test, right?
That would make it really easy. Yeah, then we can just translate these values into vascular age and just see what the difference is.
Variances.
Yeah, exactly.
Sure.
If it's less than 5 years, that's great.
Okay, it's good to know. Okay.
All right. So those are our next steps on IMT, and we should basically, in the next week, we should be done with all the IMT work, which is great. And then the model is there to be used.
Wonderful.
All right. Jonathan, anything else on the IMT front?